Okay, trigonometry mixed problems continuing. This time is a three-dimensional problems. So let's start the example 5. Part A. From point X, 25 meters due south of the base of a tower, the angle of elevation is 47. Point Y is 15 meters due east of the tower. Find part 1, the height, h, of the tower, correct to 1 decimal place. Part 2, the angle of elevation, theta, of the tower from point Y. You probably think, what does that mean? Like, all these things are not quite familiar term, isn't it? So let's do that. From point A, X, which is 25 meters due south of the base of a tower, and it has the elevation of 47, and point Y is 15 meters due east of tower. Okay, so now you're trying to sketch this in a 2D shape. I know you probably guessed it's a 3D, but if you didn't know this and you're trying to sketch a 2D, it's going to be very challenging and a bit confusing, because it says here point X is elevation is what, 47. So even you're going to do elevation here 47, problem is here 25 meters due south of the base of tower. So when you do the normal sketch, and that's, say if it's north, and then it's a south is down here, so then you have to have a north here, so south down there and 25 meters down, sort of. And then it looks a little bit too flat. It's not ideal, because if it's just a straight, it would be 180 degrees or 90, so that's not what we want. So we definitely need something different, which is a 3D. So with the base sketch for 3D is something like this. Okay, so you need to use, remember, base sketch for the elevation, depression, and SOHCAHTOA, and right angle is the right angle triangle, and remember, like a Pythagoras and other things. But with the 3D is basically that's what we do, and when you sketch it, it'll look like something like this. So what does that mean? Our north is here, our south is here, and the east and a west. Okay, and then that's the tower or cliff, whatever that, building, that it's on the right middle. So that's what the 3D is. That x-axis and y-axis, sort of north, south, east, west, is on the bottom of it, and then the building or cliff or something that is sticking out of it, the base. So it's a 3D. So I just made a something little model. So if you want to have a look at this, so it's like this, just like that. Just cut the box, and this is what it looks like. So it goes south all the way to north, east, west, and this is our triangle. Let's see if you can see this. So that's our triangle, so that's our elevation on this side, elevation on the other side, and the bottom, the base right there. Okay, so that's what we are looking at right now. Okay, so this is what this is. So that's the tower, okay, and that's the elevation from the point X, and elevation from point Y, which is the theta, we don't know. So that's the base triangle. Okay, so let's do some questions. I'll just put that one on the side. Yep. Okay, so we got this, and we are trying to put all the information here and trying to find the H. Okay, it's not too bad, because if you look at this triangle right there, I wouldn't use this one because I don't know the theta, but this triangle, I've got all the information I need because it's a right angle triangle. So I've got base, the adjacent, and that's my opposite. So opposite and adjacent, what do I get? 10, isn't it? So if I put 10 there, so 1047 is h over 25, and h will be 26.8 to 1 decimal place. So that's not too bad. And then part 2 says find the elevation, the theta. Okay, well, as long as we got h, so I'll just sketch that. So this is the part that I sort of resketch, okay, because I know the h from the part 1. So I'll just sketch that. And obviously I'm going to use the 10 again because it's O and A, which is taller. So when I do that, only thing I have to be careful because it's angle, you just have to do shift 10 and to the nearest minute 60 degrees and 46 minutes. Okay, so that's not too bad. Next question. Next question, part B. A cone has a base diameter of 18 centimeters and a slant height of 15 centimeters. Find the vertical angle at the top of the cone. All right, so let's have a look. Just going to turn this one. So first step is always a diagram. So you sketch the diagram cone and a diameter, not the radius, it's a diameter. So it's 18 centimeters all the way. Now this is the slant height. Slant height is for cones and pyramids. Okay, so the normal height that we know of is the perpendicular height from the top apex to down to the base. But whereas it's like alongside of this the side of the cone. So this is what we're looking for. Vertical angle right there. But I'm just gonna, I can't really use whole thing because it's all curved and everything. So what I'm gonna do is I'm gonna halve this, use this right angle triangle right there. So I'm gonna call this half of the vertical angle as x. So let half of theta equals x. So, and then when I find the x, I just double it, then I'll get theta. So let's have a look at that. So I'm just going to re-sketch this one right there. So that's my slant height, 15 centimeters, and that's my radius. So I'm going to halve the 18, which is 9, and that's what O and H, which is so, which is sine x equals O over H, 9 over 15, and use a shift sign, you will get that. But theta is double of that. So to the nearest minute, it will be 73 degrees and 44 minutes. Okay. Example 6. A hot air balloon floating at 950 meter per hour. So that's a speed. We got speed this time. Okay. At a constant altitude, this is a height, is observed to have an angle of elevation of 78 degrees after 20 minutes. Now, you will expect that because we were dealing with the speed, you'll have some sort of a time coming up there. The angle of elevation changed to 73 degrees. And calculate the angle through which the observer has turned during those 20 minutes. Now what that really means, we have to sketch a diagram obviously, but the diagram was given, in fact. So it was given like this. So we got the elevation, so the observer was looking at this, hot air balloon was here, right there, okay? First time was the 78, so the person standing there looking at the hot air balloon. that was right there. And then 20 minutes later, it just traveled, what was it, 950 meters per hour. Keep going, and then it stopped there, and the observer looking at it up was 73 degrees, and I mean height's still same. Okay, so here I'm going to just write 3000 as well. And what are we looking for is from here to here, the angle through which the observer has turned during those 20 minutes. So observer was standing here, going around and looking at right there. So this is the theta we're looking for. So I sort of took out all this triangle right there, and I'm going to have to work on it because to find the theta. So I need to plan. How am I going to find this? Obviously I can see this much. I can't use sine rule. So a sine rule is out. Cosine rule, definitely. But to use cosine rule, I need x, y, and I'm just going to name this m. Okay, so let's find the m first. They're all distance, guys, no speed or anything like that. So how am I going to change this? I know for a fact the hot air balloon traveled 950 meters per hour, okay, from here to there, and it took 20 minutes for it. So what's a 950 meter per hour really means? 950 meters over 1 hour. So every 1 hour, 950 meters moved. And I'm going to change this 20 minutes into hour, which is 20 over 60 minutes, isn't it? An hour. So what happens is I'm just going to cancel the hours together. So I'm going to go 950 times 20 over 60. And that will give me, if you use a calculator, I will get, I'm just quickly looking at my calculator, yes, right there. So that's, I'm just going to leave it like that so to be accurate. I don't want to put it in a decimal, but I will put it in decimal for other ones. So that's my m right there. Now x, how am I going to find x? The x is here, y is right there. That's not too bad because I can just use the right angle triangles on both sides. So x, I've got it here. It's, you can't really see the diagram. Let me see. So to find this, I'm going to use, what is this? Adjacent and opposite. So that's a 10. So it'll be 3000 over x. So 1073 is 3000 over x, and I'm just going to swap, so make x the subject, and you put that in your calculator. That's what you're going to get. Same thing happens with the y. Again, I have to use 10, so I'm going to use 1078 degrees equals 3000 over y, and I'm going to make y the subject. 3000, 1078, and now put that in your calculator. I will get 637.67. I'm just going to leave it as a 2 decimal places for accuracy. And then finally I can use cosine rule because I've got everything that I want for cosine rule. So I'm going to put that in there. 950 over 3. X was 917.19. The other one was 637.67. So let's have a look. I'm going to put 917.19 square plus whatever it's covering the theta, we have to square and then add them up. 0.67 square minus, take away the opposite to the angle that we're looking for. I'm just going to put this in the brackets and square it. 2 times whatever this 2, but don't square it. And put that in the brackets so it looks neater. And put that in your calculator. What do you get? I already calculated before. So we put it all in a calculator. you will get something like that. But if you want to, I can show you how to do it in calculator as well. So we do shift cos, because it's what? It's angle, isn't it? So I'm going to use what I've got. It's a fraction. So it'd be 917.19 squared plus 637.67 squared. Okay, this is the part a little bit tricky. I'm going to do double fraction here. 3 squared, and down the bottom 2 times 917.19 times 637 point. I hope I'm not doing wrong. And then make sure you close the brackets. Bit nervous. And then I'll press this because it's angle. So excellent. So it'll be 11 degrees in 10 minutes. That's exactly what I've got. Well done, people.